Hello and welcome. Today we're going to go over the process of deploying a Node microservice to AWS. We are not going to go over the process of creating a Node microservice. I'm going to leave that for a separate video. I have already created that, so hopefully you'll see it in the same channel. Today we're going to get started by opening up our Node microservice. I'm going to do that by opening up my terminal. We're going to move into that directory. Give it a second here. So here, my demo API is the project that we're looking at. And I'm just going to open up that VS Code, I'm going to open up that project in VS Code so we can take a look at it. The project itself is incredibly simple. It just has inside the package.json 5 scripts. The start script is the one that we care about for development, and then the production script is the one that we care about for inside our Docker image. I'll go over how that Docker image works in a second, but we build through Webpack. Webpack configuration is incredibly simple. It just specifies a target of a node. The entry file isn't strictly necessary. I just put it in there so that you can see where it is. The default for Webpack is source index. The default output for Webpack is distribution main.js. So you'll see that here in just a second. I do not have a git ignore. Oh, I do. And I'm ignoring dist. Oh, I don't know why it doesn't look like it's being ignored. Interesting. Okay. Other than that, we've got a Docker file, incredibly simple, just using the latest Node Alpine image. If you're watching this video later and you see a higher Node version, feel free, or a higher Alpine version, feel free. We're using the distribution folder that we create in the build process. We're copying that directly to the Docker image, and then we're also copying our package.json. We're exposing port 9822. You can change this to whatever you want, and we're running production. Inside our index.js, we're calling this application module. The application function is incredibly simple. It just opens a new Express application. It uses Helmet for some basic security, allows cross-origin requests, so you can make requests from Chrome or Firefox or whatever. It disallows any search engines from accessing the API. It allows URL encoding and JSON encoding. And it has a middleware to log out requests. And then it has 2 routes. One route, which is just the root route, which sends the current API version. And then a /IP route, which sends the user's IP. And that's it. I'll show how it works locally just by running npm run start. And then I'm going to open up another thing here, and we're just going to do curl localhost 9822. And you can see that this is API version 1.0. And it also logs that out here. Very easy. So as a part of the build process in AWS, we have a build spec file. The build spec file is the specification that AWS uses for the code pipeline system. It has a few phases to build, and it specifies the output artifacts, which is just a file that goes into S3. The version 0.2 is necessary. If you look up a tutorial for how to create a build spec, it'll tell you that the version is necessary. And these might change for some future version, but they'll probably be pretty similar. We've got 2 different runtime versions. This would change if you're not running a NodeJS microservice, if you're using something like Ruby or a C microservice or something like that. In our case, we're using the latest version of Docker and the latest available version of Node for our runtime of the build environment. And then in our pre-build, I'm sorry, this is a build spec for not for the code pipeline, for the code build system. They're 2 kind of intertwined systems. The code build system is separate from the code pipeline system. Sorry, I misspoke there. For the pre-build system, we just execute npm install. This is not strictly necessary in the case of having a node module that is just a vanilla JavaScript module, but for a native module, something like bcrypt, this is really important because you need to install it in the same system that you're going to be executing it in. And then we execute the AWS ECR logging credentials. This just logs into Docker using our ECR credentials. This is important because we want to push our Docker image into AWS ECR, which is a container repository. I'll show you how to create that in AWS in a minute. And then in our build command, we execute the test command in our package.json, which just runs jest. And we have 2 tests, one that's fake, that just makes sure that 5 times 5 is actually 25, which I'm pretty sure it always will be. And then it has another application test, which just starts the application itself on a random port and ensures that we can actually hit it within 3 seconds of loading. Back to our build spec here. Once we are done testing, if that's successful, we run the build command, which just runs webpack and creates a new distribution file. And then we use docker build to make a new Docker image with an image tag. This repo name, I'll show you how we specify that in a minute. I've created a .env file here. We're not actually using it, but I have temporarily put in these environment variables just so I can remember what they are. So then we actually tag that built image that we tagged previously as the repo name with this tag. Then we retag that as our AWS account tagged item, and then we push that into the AWS ECR system. After we push it, we create a new file, which is just image definitions.json. You can see that we're pushing into that file here. And we push into this string, which is just a JSON string that has a name and an image URI. The name and the image URI are these. We use this same image URI several places, as you can see. And then we specify that there's an artifact called image definitions.json. And image definitions.json is important for ECR. There's another type of, for ECS, there's another type of deployment, which is called I think a red-green deployment, which is different than a rolling deployment, which allows you to have multiple versions at the same time. We are not going to be doing that, but if you do, it's a different file. It's not image definitions. It's like image, I don't remember, image artifacts or image something else. We don't care too much about that, but that's a basic rundown of how this application works. Very simple, very simple. The video that I will I'll put online is creating this repository. Okay, so we've got that guy working. The next thing we need to do is open up AWS. So I'm just going to go into Chrome. I'm going to go into the AWS console, and I'm going to show you the basic rundown on how to actually create this system. We're going to log in as the account. This is just a test account. This is a little bit different than my production account, but it does have a few things on here. The first thing that we want to make sure that we have is actually an SSL certificate. So if we go to the certificate manager, we just want to make sure that in the region that we're going to be using, which I'm going to be using US East 2, you can use whatever you'd like, but we need to be consistent with the region that we use today. We just need to make sure that we have a certificate available for either the domain that you want to use or the subdomain that you want to use. I'm just going to use test.fullhermit.com, and test.fullhermit.com is going to point to our newly deployed API. Okay, so once you've made sure that you have a certificate, we need to head over to ECR, which is our container repository, and we need to create a new repository. In this case, I'm just going to call this demo API test. Maybe not test. We're going to call this demo API video. For whatever reason, that's just the name that we're going to use today. So demo API video. Now we've created this repository. This is my account ID. This is the region that we're using, and this is the repository name. So when we create our build, I'll show you why those three things are important. For now, we just need to note them. So I'm going to open this guy back up in VS Code, and I'm just going to add those to my environment variables. You'll see that I had previous values here. Just ignore that. So we're using US East 2. This is my AWS account ID. This would be different for you. This is the name of my image repo here, and then the container name. This is used in ECS. I'll show you how to use that in a minute. And then we've got an image tag. We're just going to use latest. Okay, so the next step here is you can go one of two different ways. We can create the code pipeline next, and just not actually deploy it, which I kind of like that. I kind of like creating the code pipeline first. So I think we should maybe go about things in that way. So we'll go to the code pipeline. We're going to create a new code pipeline. This one, the name doesn't matter, but I'm going to call it the same, which is just demo API video. Today, the new service role is good. Where our advanced settings don't matter. The source provider, I'm using GitHub. You're probably going to be using GitHub. My system here is already connected to my GitHub, but if you click this button and you're logged into GitHub, it will just ask you for permission. Once you give it permission, it'll come in here, and we're just going to do demo API. I've already pushed my repository to this. I've already pushed my code to this repository. So make sure at this point that you've already pushed your code to a repository. I'm going to specify the master branch. You can specify whatever you want. It could be production or whatever master. If you're, if you don't know what it is, it's probably master. Our build provider, we're going to use code build. We're going to create a new project. We need to make sure that this region is the same. For the code build project, this name also doesn't matter, but I'm just going to call it the same, which is demo API video. We're going to use a managed image. We're going to use Ubuntu. We're going to use the standard runtime. We're going to use the latest image, and we're going to allow it to always update to the latest image after this. We do need a privileged build because we are building a Docker container, our Docker image. We are going to need a new service role. Very, very important. After we create this service role, we need to go into IAM, and we need to add an additional value to this role. We need to add, I'll show you in a minute, but it's very important that we add ECR to this role. We do have one bit of additional configuration. We need to specify some environment variables. These environment variables are the environment variables that we are adding inside our build spec. So our build spec is going to use these environment variables to fill out the necessary variables inside this build configuration. So for our AWS default region, it's US East 2. For our image repo name, and these will be different for you, but the image repo name, this is the one that we used inside ECR. For us, we use demo API video. The image tag is latest. Image repo, and then our account ID. Your account ID you'll find inside. I'll show you how to find it. Your account ID you can find up here under my account. And this is your account ID here. Okay, one more. We need our container name. So the container name, we haven't actually created this yet, but we will. I recommend naming it the same as your image repo name, just for brevity's sake. All right, so we're going to call this demo API-video. And I believe that's everything that we need. That's 5. Yeah, that looks good. We're going to use the build spec file inside our GitHub repo. I don't care too much about logs. You can use logs, not use logs, whatever you'd like. I say it's pretty smart to have your output logs, because otherwise, how are you going to know if something fails? Excuse me. Okay, so we've successfully built that. Before we move on to the next step, it's very important that we add that permission to the role in IAM. So come into IAM. Yes, we're going to leave that site. Come into IAM, look at your roles over here on the left side, and then you're looking for the code build. This is for the code build service. Inside here, you need to attach one more policy. You don't have to attach the full policy, the Elastic Container You don't need to attach full access. You could attach a different policy. I'm going to give full access, but you can look at the permissions that that you actually need. I'm just going to use all permissions because this is a test, so I'm not going to spend the time to figure out which individual permissions we need. But if you want to be more secure, you're welcome to do that. Okay, we're going to move on to the next step, and we're just going to skip the deploy stage because we don't have a code pipe, because we don't actually have an ECS cluster yet, so we can't deploy it anywhere. We're going to create this pipeline. After this pipeline is created, it should instigate a first build. Once it does its first build, it should actually create the task definition, the ECR image that we're going to use in the task definition. I think that was a successful build. Yep, it succeeded. Cool. So the nice thing about this is now we already have an automated build system to build our Docker image, and that's really the most important part of this process, because now every time you push to master, it will create a new image inside your AWS ECR system. So then you could, at some future point, if you wanted to, manually deploy with the newest image. And that would make your life a lot easier already. So let's move over to ECS and let's create our Docker, well, not our Docker, let's create our cluster. This needs to be an EC2 plus networking cluster. Our cluster name, this can be whatever you want. I'm just going to call this basic ephemeral cluster. You don't really use his name anywhere, so it doesn't matter. I'm gonna use on-demand instances. For my instances, because this is a test thing, I'm just gonna use T2 micros. They're cheap. It costs about 15 bucks a month per instance. I'm gonna use 2 instances so that you can see how it's working inside a cluster. I'm gonna use my SSH key. If you don't have an SSH key, you can open up your EC2 service. You can go over to your key pairs, which are also down here, and then you can import a key pair from your laptop if you already have an SSH key. If you don't, you can generate one. You can find that key pair if you're on a Mac by catting, well, if you're on a Mac or Linux, your SSH folder ID rsa.pub. This is my SSH key, my public SSH key. You're welcome to add that to anything you want, then I can access your service. But the nice thing about a public key is it is public, so that's why I don't mind showing you. For our VPC, I'm going to use the default VPC. I don't know why it has you try to create a new VPC. I don't really see the value there, but I'm going to add it to all of the subnets available to that VPC. We are going to create a new security group, and this guy's really important. For some reason, it only allows you to create one inbound rule here. So after we create this security group, we will have to go in and allow port 443. Actually, you know what? I don't think we will. We will have to add port 443 to the security group that we use with our load balancer, though. Okay, so we're just going to leave this. We're going to let it create a new security group. If you don't allow this to create a new security group, you should add to the security group that you use the permission to access port 80. And if you do look at this security group, one really important thing to note is that by default, your default security group has an inbound rule to allow all traffic from all protocols on all ports only if the source is this guy. So if you look at your security group, if you don't see source as a 0/000 whatever, if you don't see this guy, then it means that you are not allowing access from outside of your security group. So super important. You've got to allow at least traffic on port 80 from outside sources into that security group. But this guy will create one for us, so we don't need to worry about that. We don't have any tags. We don't need additional container insights. This will create the CloudFormation stack and the ECS cluster and the whole 9 yards. And then we're going to move on to the next step, which is creating the load balancer. I'm going to assume this is going to be successful, and let's just move on to the load balancer now. So inside EC2, on the left side, you'll find your load balancers. Go ahead and create a new application load balancer. Inside application load balancer, call it whatever you want. We're going to call it the demo API balancer. It is internet facing. We're going to use 2 protocols. We're going to use HTTP and HTTPS. You could just have HTTPS and forward HTTP to HTTPS, whatever. Important to click all availability zones here. For some reason, at one point in my past, I've clicked only 2 of these availability zones, and I ran into all sorts of issues. So click all 3 of those availability zones, or all that are available to you. This is the certificate that we specified earlier. So in the very beginning of the video, we talked about how you need to have a certificate if you're going to use this with HTTPS. If you haven't already created this, just head over to the AWS certificate manager. Inside the certificate manager, request a new certificate and specify your domain name. When you specify your domain name with the certificate manager, you might as well do domain.com and star.domain.com. No reason not to do that when you're creating that certificate. I've already created one for fullhermit.com and star.fullhermit.com. So that's the one that we're going to use here. Next, we're going to configure our security groups. We can use the default security group here. However, very, very important with this load balancer, the load balancer needs to have both port 443 and port 80 available from anywhere into this security group. So if you're going to use your default security group, that's fine, but you need to specify those rules inside that security group. We'll go do that here in just a minute. We're going to make a new target group. The target group name is just going to be demo API-video. The protocol's port is HTTP, and our health check is on /. You can change your health check here. We aren't going to add any instances to our load balancer yet, and we'll create that load balancer. The load balancer is presently not facing anything. Let's go fix that security group so that this guy can receive traffic from outside of the network. Inside the security group, go to your inbound rules, edit. We're going to allow all traffic on HTTP from anywhere. And then we're going to add HTTPS from anywhere. And we'll save that. Then we'll allow all traffic from port 80 and port 443 from anywhere. Hold the phone. Where did my all traffic, all from this security group? Dang it. All right, so VP, no, SG, this guy. You need to make sure that you also leave the rule that says allow all traffic from your security group. I don't know how I deleted that. I must have just changed one of the other rules. Okay, so we've got all our traffic coming into the load balancer. We've got our load balancer created. Let's go into our cluster and let's actually create the task definition. For our task definition, this is an EC2 task definition. The task definition name, it doesn't matter what you use here, but this is what we specified in our environment in here. This is, where did I see that container name? Container name, this guy here. So it's very important that this name is the same thing that you use here and for your container definition. There's something weird about using a different task definition name and a different container definition name. It gets spooky. So just use the same one. We're just going to say demo API-video. We don't need a task role. The default network mode for a Linux box is bridged. So we're just going to leave that default. We don't need any task size. We do, however, need to create this container definition. Now, this is the container name that we used here, in here. And this was the container name that we specified in our code build system. Code build creates that this guy, the image definitions. And the image definitions is what the deployment system uses to grab this container name. So our container name is going to be, again, demo API-video. And our image repo is the ECR repo. So let's head over to ECR really quick. That's this guy here. So you can just copy that fella. It does need to have a tag. We specified a tag of latest. We specified that tag here. So image tag, whatever you used as the environment variable inside your code build environment variables is the tag you need to use here. We need a soft limit for a node process. I just used a soft limit of 256 megabytes. We need to map port 0, which allows it to be accessed from the outside world, to our inner container port, which is 9822. This is the port that you exposed in Docker. So if you look at your Docker file, you've got this exposed port. On the right side, you use your exposed port. On the left side, you use 0. And then you add your container definition. The rest of it we can leave as the default. Now we can go to our cluster. We can create inside our cluster a new service. This is an EC2 service. It uses our task definition, uses the latest revision. We use our cluster. We can specify a service name of whatever you want. I'm just going to say demo API-video again. Daemons allow they force one task per container. Replica allows you to have multiple tasks per container. We want to have 2 tasks for now. We're going to have a rolling update instead of blue-green. The difference here, if you use blue-green, you have to change your build spec, and it can't be an image definitions file. It's got to be something else. We're going to use rolling update, and we're going to use a balanced spread. That's fine. We don't really care too much about that. Okay, we've already created our load balancer, so we're going to come into the application load balancer. We're going to specify that particular load balancer. Then we need to add to that load balancer HTTP, and we're going to use the target group that we created inside that load balancer, and that's it. That makes our life easy. For service discovery, we can turn that off. We can go to our next step. We don't want auto scaling. You can turn on auto scaling if you want to, and we're going to create our service. Once this is created, the service should grab our latest tagged image from ECR, and it should immediately deploy it. Then based on the health checks inside the target group, which you can find inside EC2, it will verify that that deployment was successful. So this is the target group. You can look at the health checks. This is where the health check is specified. So let's take a look inside our cluster, inside this service. It should have a deployment. We can look at the desired count. We have 2, and we've got 2 running. Now we can look at our events, and we can see it looks like it registered both targets in our target group. So now we should, theoretically, fingers crossed, we should be able to access the service itself by going to our load balancer. Inside our load balancer, it's got an externally facing DNS name. So we should be able to copy this guy, pop it into our browser, and if everything went well, it looks like it did not go well. We missed a step somewhere. This guy is not externally facing yet. Oh, we got a gateway timeout. We might just need to wait for a minute for that to fully deploy. Yeah, let's give that just a minute. Let's make sure this guy's active. Yep, this guy's active. Inside ECS, I might have just been too quick on the draw. This service is active. We've got our 2 events. They're both registered. Let's look at our deployment. Our deployment is successful. Let's look at our events again. There's nothing weird in here. Normally, if something's unhealthy, you'd see it here in these events. The gateway timeout. Yeah, that's not looking too good. Okay, let's take a look inside ECS, add an individual task, and see if we can access that from the outside world. You can just open up this guy and hit this external link. Ah, something is not working here. Probably the security group. Okay. What did I miss here? Well, we get to do a little bit of debugging here. Make our life a little bit harder. That's fine. We'll go to that EC2 instance and look at the security group that it's using. It's using what security group? This guy. This guy's security group has an inbound rule, port 80. All right, from anywhere. How about we edit this guy to allow port let's just do all traffic from anywhere temporarily. We're going to save that. Let's see if that fixes this guy. All traffic from anywhere, from any source, should be able to come into this fella. Okay, that guy is responding with something bad. It's possible that my service itself is messed up. Not likely, but it is possible. So let's go to the EC2 instance. Oh, it stopped. It could possibly have stopped because the health check couldn't access it because our security group didn't allow access to the health check endpoint. Let's go look at our tasks again. Now we've got 2 tasks. This guy here. Let's see if we can access this guy. Can we? We can. Okay, now we can access it. So it was that security group. Shoot, sorry about that. Should have mentioned that. Okay, so the host port 32769. Now, theoretically, this guy, aha, good. Okay, so our demo API balancer now can access that EC2 instance. So I apologize, I went pretty quick there, but the way that I fixed that was by looking at the EC2 instance, one specific EC2 instance, and I looked at the security group that was attached to that specific instance, which was the security group that was created automatically when we created the ECS cluster. And inside that security group created by the ECS cluster, we needed to add additional rules so that we could access ports from outside of our network. Now we actually don't want this to be accessed from anywhere. Really, we technically only want this to be accessed from our default security group and all traffic from the current security group, which is this guy. If we change this, what you'll notice is first we can no longer access directly. We can't access that port, but we should still be able to access it from the balancer. So the balancer can hit it, but nobody can hit it directly, which is what we want. So then, now that we have a balancer and we have the ECS cluster, we should be able to go into our Route 53. We should be able to look at our hosted zones and click on the domain that we added let me delete these other record sets that I'm not using. We should be able to add a new record set in, which we're just going to call this test.fullhermit.com. It is an alias, and we're going to specify the ELB cluster here. This is an application load balancer. We're going to create this. Now, once this propagates, we should be able to hit test.fullhermit.com, and we should be able to see our API. This might take a minute. There we go. Now we can go to test.fullhermit.com, and we can go to https:/test.fullhermit.com, and now it's secure. So the other change that I would recommend making is inside our load balancer, EC2, load balancers down here. Inside the new load balancer that we created, we really ought to change these listeners. Instead of listening on port 80, we should delete that rule. We should add a new listener, which listens on port 80, but instead it should redirect using a 302 or a 301 if you'd like to HTTPS 443. Should be able to check and save. Now, if somebody tries to access HTTP instead of HTTPS, it'll redirect them to the secure endpoint, and our connection is secure. And there you go. That's the process of deploying a node service to an ECS cluster. Let me demonstrate really quick how this process can how you can add one more step to automatically deploy additional pushes to your master branch. So let's head up to our code pipeline. Inside our code pipeline, let's go to the pipeline that we already created, and let's add an additional step, which is under edit and add stage. This is going to be deploy. We're going to add an action group, which is just a deploy action. This is going to be, for us, we're going to use Amazon ECS. This uses the default artifacts. We don't need to change that. The cluster name is the basic ephemeral cluster. And our service name is Demo API Video. We're going to use the default image definitions name, default timeout, default variable namespace, and check the minimum number of input artifacts for this provider. Right. We do need to specify. So we're going to use the build artifact as our input artifact. Here we go. So now we have an auto deploy stage. Let's go ahead and change this API. We're going to make a new endpoint maybe. Let's just go into application.js. We're going to make a new endpoint, which is going to say hello, and it's going to output hello world. Cool. So now we should have an endpoint. Let's test that locally just to make sure that it works. Hello world, looking good. So let's do a get status, get add dot, get commit -m, added hello endpoint, get push origin master. Now, as soon as this master branch is updated, our code pipeline should automatically be, as you can see, it's in progress now. So we'll give it a minute, it'll build, and then, oh shoot, did I not save that? No, oh gosh, dang it. Somehow I managed to not. No, okay, we'll see if we can beat out the other stage here. There's the build artifact, basic ephemeral cluster, demo API, image definitions, done, save, yes. Okay, I don't know if that was fast enough. We'll see if that was fast enough. It probably was not. And phase is complete. That was a success. We can go back to our pipeline. This second deployment, totally good. Let's go to the actual pipeline itself. And it failed. Okay. Why did it fail? Wait a second. What? There's no failure here. Why did it say that it failed? Excuse me? Everything was a success, but CodePipeline says that it was a failure. It's possible it's because I was in the middle. It was in the middle of that build. So let's retry that. Yeah, the pipeline definition has changed. So let's release a change. Yep. We may move on and try some additional things in a minute, but you can see here as we refresh this guy, it's still running both the old version and the new version, and our load balancer is switching between all those containers. Eventually, once those containers are stopped, it will only be on the newest version. But hey, you're good. That's how to do it. Good luck. If you have any questions, hit me up.